Going into the home stretch here, I'm going to take you through the proof of fulfillment of the RFP, and then basically show you what we really need in order to finish up and go to a real PR, since we're in between conceptual review and PDRA. Go ahead, next slide. Here you can see the orbiter's RFP requirements. These are all of the atmospheric requirements, the planet's magnetosphere requirements, thermal requirements, mass distribution, and all the temporal evolution. With the instrument suite provided by the customer, we are able to meet all of these requirements to the resolutions designated in the RFP. Next slide. Here the probe requirements are listed again, and you can see that we do meet all of these. There is one note to be made. The customers provided instrument for measuring samples from 100 millibar to 500 to 5 bar. Actually can't start taking samples until 150 millibar. So there is a slight lean on that requirement. However, since this is a customer provided instrument, not fulfilling a customer provided requirement, and we've discussed it with him, it's considered okay, and we fulfill this requirement. Additionally, the UPS, it only has really one job, and that's to deliver. And it does. Assuming that it operates nominally, it will deliver each of them will deliver one probe to Uranus and complete the RFP there. Here.
Have you considered the local infringement that you're embarked on here?
I'm sorry, the local infringement?
Local infringement.
No, unfortunately we haven't.
We'll get our legal team on it.
Yeah, we'll get our legal team right on that. Next slide, please. Here you can see all of the miscellaneous requirements. So we do meet the launch requirement with UPS. We get off the ground by December 31st, 2020. And we do fulfill the communication, power, and thermal requirements all set forth in the RFP. Additionally, as you saw in the reliability slides, we do meet the overall mission reliability of 40%, and from what we learned about rounding earlier, we do meet the 80% orbiter probe combination reliability constraint.
For the single point failure, well, we do have some degradation with regard to the probe, right?
With regard to the probe?
With the probe, if the switch didn't work, to turn on the equipment, if it didn't turn on.
The single point failure requirement that we see here, we take from a mission perspective. So a single probe failing isn't a single point failure from a mission perspective.
Oh, you're considering the probe redundant?
I'm going to actually, no, sorry, the probe is not considered redundant. So I guess I just kind of go back my word. I'm going to pass that off to someone who knows more about this.
Yes, so single point failures, we're thinking of something that would cause a total mission failure. And so while we do have vehicle single point failures, which would cause the UPS vehicle to be a failure in its own, we will still complete part of the RFP with the rest of the mission. So we don't have anything that will completely be sufficient.
Okay, so you're saying that you want to accept some degradation?
Yes.
And you have to,
Yeah, there was
you should coordinate that with the
I also have a specific point to speak to about the instruments. If the timer does fail and the G-switch must be thrown in that event, we would lose the pre-entry data and the early entry data. However, that all happens and all of the G-switch will be thrown a long time before we hit the 0.1 bars. So the RFP requirement to measure from 0.1 bars to the 5 bar level will be met with the lane that we previously discussed, but we would lose the pre-entry data that the entry dudes would be all kind of crazy about.
Okay, so you define what's acceptable in terms of probe data, and the amount that you would lose is not critical, is that what you're saying?
Yes.
Well, it's not a requirement to collect this, is what you're saying.
If there aren't any other further questions about the RFP, one more slide left, and that is moving forward to PDR. In order to really move into a real PDR, we have to do some form of cost analysis and mature our scheduling. We also need to mature our ConOps. There are some feasibility studies that need to be done, especially with the Pro, in order to move into a real PDR. Additionally, we want to just continue our design analysis so we can have a better refined overall mission when we finally get to PDR. And finally, the action items that you guys have graciously provided us today, we will have to handle those in order to move forward to PDR. Now, any questions about this? I would like to say thank you very much for listening to us, taking time out of your busy days to come here and see our design. This is a 9 months culmination of work, and it's really exciting to kind of see it all come to fruition and hear what you guys have to say. And if there are questions that you guys have from the system level, we'd be happy to take them or direct them to the team. Otherwise, we can talk directly to the team members that you have to address or feel like you need to address right after this presentation. So if there aren't any system level questions, excellent.
So I hope you have enjoyed the day. You've seen the work that the students have done. Just think that this has been just an 8-month process for them, starting from pretty much basically no real spacecraft integrated system architectural background. So they have done an excellent job in pulling together all the technical work that they've done, understanding the spacecraft subsystems, what they go into, going to multiple reviews with industry and getting lots of feedback, and have taken that feedback to heart and have improved their design tremendously over the 8 months. So they can feel very proud of what it is. The parents can feel that they have done a very good job and have learned a lot in this last 8 months, probably more than they ever thought they were going to learn about a spacecraft. So I want to thank you very much. I do have a couple of comments for the audience. The technical reviewers, please fill in the ABET forms for me on there and pass them on to myself or Chelsea when you do it. Action items. If you haven't asked all the questions and there's still some open issues and stuff like that, feel free to ask the action items on there. They do have a requirement, as we'll discuss on Monday, to answer effectively the response to the action item in their final report, which is due in 2 weeks on that. All of you will be given a CD, we'll mail it out to you. It's a very large file, 700 page or whatever number document is fairly large. We'll send that out to you for your final review. You guys can take a look at it and see what they wrote up basically on there. So, appreciate your time. If you have any feedback to the students, they are more than happy to take it. Everything that they've heard from you guys in the past has only positively enforced and helped them in their progression for this class. So, thank you.
Before you guys will run off, I'd like to say, this is about the 6th or 7th one I've been to. This is one of the better ones I've been to.
Yeah.
I think you guys did a really good job. I particularly want to congratulate the guys who took a look at risk. I think this is the first time we've seen something that thorough, and it's a good start, and I encourage you to carry it forward for the future years, because I think that's something that's really important. It's something that we care about in industry, and I want to thank you guys for putting up with us torturing you.
We enjoyed it.
You guys are so good. You're ready for it. You're ready for industry.
All right.
Just some additional notes on top of what Dave was saying. This is my fifth presentation that I've seen, and you guys did go beyond the last 5 years of this. Some of the level of details that you went into IMTs. There are a lot of lessons learned from this presentation, I feel like, but the extent of detail you went into it was far beyond us. This was like 4 years, 5 years ago. Utilizing tools, STK, you guys took the time to learn the industry tools that will come useful when you come into the industry. That was very nice. You mapped out your analysis with MATLAB tools. That was a good lesson. And animations.
Yes.
So I wanted to make one comment about the class, just so all of you that have been observing the past years and stuff like that. John was one of the leaders of about 3 years or 4 years ago. One of the things that we tell the class very early on is that they need to set schedules and meet schedules and communicate well. Otherwise, this week before Symposium is ultimately hell. It has happened every year except for this year, where students were sleeping in the design room and making all their charts in the last week, where this class has effectively made it, I don't want to say easy, but they put a lot of time in this last week, but it wasn't to the extent that some of the other classes have done. So they did a much better job of managing and setting up their schedule and getting everything done. So they set the bar down next year, they tell the students again and stuff like that, see how effective they are on it and stuff like that. So very happy with this year's class. We have 44 students. It's the largest class that we've had so far. It does take a lot of effort on the students' parts to communicate effectively and do the right work, making sure that everything is covered and not thought that somebody else is doing it, or that multiple people are doing exactly the same thing. So, feel proud of that. So, congratulations. Thank you very much for the day. Feel free to have discussion with the students.